3. um, we're going to do the derivatives of lns, which is the natural logarithm, and log. And remember, whatever applies to log, whatever rules you have, also apply to ln. So earlier today we did the derivatives of e to the x, and then the derivatives of any other exponential, like 2 to the x or 5 to the x. E to the x is fairly easy, and in the same way ln x is actually easier than doing logs. So I'm just going to skip all the background, the proof, and just give you the derivatives at this point. So the derivative of ln x is 1 over x. Of course, if that were ln 2x, then it wouldn't be 1 over x, it would be 1 over 2x, and then you'd have to dot by the derivative of this expression. So if it was 2x, then you'd have to dot it by 2. So really the derivative of ln is pretty easy. It's a little bit easier than doing the derivative of logs. Okay, here's some examples. I already did them because I messed up the recording, so I just left them done, and then I'll do some of the other ones with you. So in this case, we have ln of 7x. So the derivative is going to be 1 over this quantity, so it's 1 over 7x. But once again, it's not just an x, it's a 7x, so you have to make sure you use the chain rule and dot by the derivative of this. So dot 7, and then of course the 7's cancel, and you just get 1 over x. Same thing with this one, so it's ln of a quantity, so when you're deriving it, you have to do 1 over that quantity, but then you have to derive the inside, so you have to dot 10x, so you just get 10x over 5x squared minus 8. Now, all this stuff in blue, you always have to be careful when you're doing logs or lns. You know you can only log or ln quantities that are greater than 0, so you can't log a negative. So in this case, 7x would have to be greater than 0, or x would have to be greater than 0, not greater than or equal to, because you can't ln 0. Same thing in this case here, 5x squared minus 8 would have to be greater than 0. So I was just thinking of it as a quadratic. So 5x squared minus 8 is this picture right here. It's just a quadratic, a parabola that opens up. I solved for the zeros. So the zeros are plus or minus root of 8 over 5. So that's root 8 over 5. That's negative root 8 over 5. So where this thing is positive is for things greater than root 8 over 5 or less than negative root 8 over 5. So these squiggly parts are where the parabola is positive. So that just happens, if you were trying to solve this or solve for x, you should always watch your restrictions. So if you solved this and you got x equals 0 or something, then obviously that would not be in your domain, because your domain is only things greater than root 8 over 5 or less than negative root 8 over 5. Okay, the next one, so ln of, this time our quantity is 3 to the x. So again, the derivative of ln is just 1 over the quantity, so it's 1 over 3 to the x. But the problem is you then have to derive the inside. So the derivative of this you should know is, whenever you're going to derive an exponential, the first step is to just write the exponential down so it doesn't change, whether it's 2 to the x or 5 to the x. In this case, it's 3 to the x, so you write down your 3 to the x. But then to continue the derivative, you have to ln the base, so ln 3. These obviously cancel, and you end up with just ln 3. Okay, I think the next one's a little bit harder. Okay, so this one, make sure that you notice that it's actually going to be a product rule, right? Because it is 2 quantities multiplied together. And this one we actually do have to solve. So you need to make sure that you look at your domain. So we know that 8x cubed, so we know that 8x cubed has to be greater than 0, which means x has to be greater than 0. So if you get an answer for x of negative 3 or something like that, then you know that it's not going to be an appropriate answer. Okay, so the derivative, f prime of x. So like I said, it's a product rule question, so it's a derivative of the first thing times the second thing, plus the derivative of the second. So you're going to have to be careful with this one. So it's ln of a quantity, so it's 1 over that quantity. But because it's an 8x cubed, you then have to dot it by the derivative of the inside, so that's 24x squared. So all of that is the derivative of ln 8x cubed, and then of course you have to multiply it by your first expression, which is x squared. We can fix this up a little bit, so that's 2x ln 8x cubed. Here the 8 and the 24 make a 3, and then on the top you have an x to the 4, and on the bottom you have an x cubed, so it's just plus 3x. Now, don't forget this question is actually about setting the first derivative equal to 0 and solving. So generally when you solve these, there's different things you could do. So on the note I posted last week, I think in the note they actually played around with this 8x cubed and made it a 2x all cubed, and then played around with some log rules or some ln rules. I'm actually just going to solve it by common factoring out an x, because I think that's what you would do anyways. So that's 2 ln 8x cubed. I think it's just a little bit easier this way, plus 3. So I want to solve this for x. So remember, it's just like solving a quadratic or anything. So you want to know what makes the first bracket 0, and you want to know what makes the second bracket 0. So of course, from this bracket, you get that x is 0. Now, can x actually be 0? If we go back up, we know our answers have to be greater than 0. So we actually know that's not going to be, we're going to have to throw that answer out. And then from this bracket, you get that this bracket equals 0. I'm just going to move the 3 over and divide by 2. So I'm going to get ln of 8x cubed equals negative 3 over 2. Now I need to solve for x. So you know how to solve logs. Lns are no different. So you did it last semester in advanced functions. So the way you solve for a log is you have to undo it. So same thing with a ln. So I'm going to undo the ln, and the opposite of lnning is raising it to the base e. So what you do to one side, you have to do to the other side. And don't forget why we did that, right? So I'm trying to get the x by itself, so the e and the ln undo each other. So I have 8x cubed equals e to the negative 3 over 2. So if I really want to get that x by itself, I'm going to divide by 8 and cube root it. So x equals e to the negative 3 over 2 divided by 8. Instead of cube rooting, I'm going to put it all to the 1/3, because that is the same as cube rooting anyways. So x equals, when you simplify your numerator, a power to a power, you multiply, so the 3's cancel and you get e to the negative 1/2. And the 8 cube roots nicely, and you get a 2. And that's an okay answer, but you could say that that's, don't forget e to the 1/2 is a root e, so since it's a negative 1/2, it's on the bottom. Oh, there's a little message for me. I'm going to rationalize the denominators. I'm going to multiply by root e over root e, and I'm going to get x equals root e over 2e. So again, this answer right here, e to the negative 1/2 over 2 is good, but you know, we kind of don't ever leave negative exponents, so really you should move that to the bottom as a root e, and then we kind of don't ever leave roots on the bottom. Okay, so that's it for that one. This one we want to find where the tangent is horizontal, so essentially it's pretty much the exact same question. So you want to solve for x and find, now this time you have to find the point. So once you find x, you actually have to sub it back in and find y as well. So you want to find the points where the first derivative is equal to 0. So of course you need to find the first derivative. Okay, so we haven't had one like this before. So you're going to derive the whole thing first. So that's easy. You're going to bring the 2 down and reduce the exponent by 1, right? So it's going to be 2x ln x to the 1. But then, of course, you have to derive the inside. And the inside is actually a product rule, right? Because it's an x times a ln x in there. So as far as deriving the inside, it's going to be the derivative of the first thing. So the derivative of x is 1 times the second thing plus the derivative of the second thing. So the derivative of ln x is 1 over x times the first thing. So that's just a product rule. So you did the whole big picture. So the big picture was to bring the 2 down. And of course, you never touch the stuff in the brackets. So bring the 2 down, do all that to the 1. But then you have to do the product rule on just the inner stuff. Okay, so this is 2x ln x. And this is going to reduce to ln x plus 1. So once again, we want to know where the tangent is horizontal, which really means set your first derivative equal to 0 and solve. So again, you know, like I said, go back to grade 10, and when you solve these things that are already factored, you just think of what makes each bracket 0. So what would cause a 0 in this bracket? Well, that would be x equals 0. For this one, you need to find what value of x would make ln x equal to 0. So what you want to do for that one is you actually have to solve it. So again, we just did this a minute ago. How do you undo a ln? Well, you do e to the ln x, right? I need to get that x by itself. So the opposite of lnning is e-ing it. I know that's really poor English. These cancel, and you get x equals e to the 0. But e to the 0 is really just 1. And then from this bracket, we have to get an answer. So we need to know when ln x would be -1. Really, ln x plus 1 equals 0, but I move the 1 over. So again, to solve for x, the opposite of lnning is raising it to the base e. So once again, these cancel, and I finally got my nice little x by itself. And the answer is 1 over e, or e to the -1. Now, way back, and you know I'm really bad for this, I didn't look at my domain. So what kind of numbers am I allowed to ln? Well, I'm only allowed to ln positive numbers, so I know that x has to be greater than 0, which throws this answer out. So x definitely can't be 0. X can be 1, that's a valid answer, and 1 over e, don't forget that's just 1 over 2.7, which is just some nice little decimal, but it's positive and it's greater than 0, so it's a perfectly good answer. So, now don't forget this question said find the points. It didn't just say find the x values. So you actually have to find the points. So one point is 1 comma something. And of course you're just going to stick a 1 in here. So it's going to be 1 times ln 1 squared. And ln of 1 is actually, I don't know if this needs explanation. Okay. Okay, so I'm just going to put a 1 in there. I'll maybe do it down here. So f at x equals 1 times ln 1 squared. Now, you could just do ln 1 on your calculator. This already came up either in this note or in one of the other notes from today. Ln of 1, don't forget that's really ln of e to the 0, because e to the 0 is 1. Right? And then ln and e cancel each other out. So ln of 1 is just 0, and 0 squared is 0. I mean, nothing's stopping you from just taking your calculator and going ln 1, but really, that's just something you should know. You should be able to do some of them by hand. And then the other thing is I also need to sub in a 1 over e. So 1 over e is the other point I need to find. So f at x is going to be 1 over e ln 1 over e all squared, which is 1 over e. And don't forget, this ln of 1 over e is really ln of e to the -1. I'm going to actually rewrite it like that, which is 1 over e, and then these cancel, so that's times -1 all squared, which is really just 1 over e squared. Because it's 1 over e times 1 over e, which is 1 over e squared. So that's the y value here. Yeah. So those are the two places where the tangent is 0, or where the tangent is horizontal. Okay. Now we're going to do the derivatives of logs. So you know ln is just 1 over the quantity. So the derivative of a log is actually harder. It's like exponentials are actually harder than e to the x. So the derivative of this, it starts very similar to ln, so it's 1 over the quantity. But then in the denominator, you have to ln the base. So it's going to be ln a. Sorry, that doesn't look very clear. So it's 1 over x and then ln the base, and in this case the base is a. So if you were doing a log base 3, then you would do ln 3. And it's important to remember that if this was not an x right there, So if it was log A with a 2x, then you would have to dot by 2 because you always have to derive the inside. Always, always, always. So we'll do a couple of these examples. Oops, dy dx. So dy dx, so just like ln, it's 1 over whatever you're logging. So in this case, it's 1 over x, but you then have to ln 6. And you really just need to learn these rules and as well watch your domain here. So x is going to be greater than 0 because you can only ln things or log things that are greater than 0. And here as well, if you want to do your domain right off the bat, x is greater than 0 because you can only log things that are greater than 0. So this one, dy dx, so you got to remember your rule, a couple steps. So it's 1 over the quantity that you're logging, so it's 1 over x squared, but I have to ln the base. But I have to remember that there's more to this quantity than just an x, so I also have to dot by the derivative of x squared, which is 2x. And then an x on top and an x on the bottom cancel, so I get an x ln 12. By the way, don't do anything crazy. You know this from last semester. Do not cancel a 2 with the 12 or anything like that. Ln 12 is attached. It's not just a 2. This one, you have to remember this is not all being logged. The log is only applying to the 5x. It really should have brackets around it. So you're not logging the whole 5x plus 7x squared. You're just logging the 5x. Okay. So again, 5x has to be greater than 0. So you can remember that x does have to be greater than 0 because you can only log things that are greater than 0. So dy dx equals, so you derive a log by doing 1 over the quantity you're logging, but ln the base, whatever the base is, in this case it's an 8, and because the 5x is more than just an x, you also have to derive the 5x, so you got to dot 5, and that's the derivative of all that, and then the 7x squared, you've known how to do that one for a long time, so that's just a 14x. Now the 5 on the top and the 5 on the bottom are going to cancel, so you're just going to have 1 over x ln 8 plus 14x. And again, don't forget, x is greater than 0. So they're not really that hard. You just have to learn the rule. So it's 1 over the quantity, ln the base, and don't forget to dot the quantity if you need to. Okay. So this is another one. Again, this one says to solve. Oh, it looked a lot like the other one. I guess it has a root x, though, so it's a little bit different. So we're going to set the derivative equal to 0, and we're eventually going to solve for x. Notice it doesn't say find the points, so you don't actually have to sub your points back in. It just says solve for x where the derivative is 0. So let's remember right off the bat, since we're solving especially, that we need to do the domain. So we know you can only log things greater than 0, so x is greater than 0. Actually, 8x cubed is greater than 0, but that means x is greater than 0. Okay. Obviously a product rule question here because we have two quantities, right? So dy dx equals, the derivative of the first one is, don't forget that's x to the 1/2. So that's 1/2 x to the negative 1/2. Can I just do this as 1 over 2 root x? You should be getting good at that one by now. So that's 1/2, because you bring the 1/2 down, x to the negative 1/2, but negative 1/2 means right on the bottom. So that's the derivative of the first thing times the second, plus the derivative of the second, so you're going to have to do 1 over the quantity that you're logging, ln the base, but you have to dot by 24x squared. And again, that's just the derivative of the second quantity times the first. Okay. So we want to think about exactly what we're going to do with this. So let's rationalize the denominator here. So this is going to be a root x top and bottom. So that's going to be root x log base 3 of 8x cubed over 2x plus, so we're going to have a root x for sure. And again, the 24 and the 8, they're going to make a 3. And you're going to have an x ln 3 on the bottom. Can I put the 3 out front? And you're going to have an x ln 3 on the bottom. We are going to have to set this equal to 0 and solve it, but let's common factor it first. Okay, so we can pull a root x out. Sorry, I'm just looking at something. Oh, they're playing around with this again, so I'm going to leave it like that. So let's just pull out a root x. And we could pull an x out of the bottom as well, but I guess it's fine. So we're going to have log base 3 of 8x cubed over 2x plus 3 root x over x ln 3. Oops, I just noticed I forgot to take out my root 3 here, or sorry, my root x. So that is actually gone. Okay, so now it's just a matter of solving this. So once again, if this first quantity, oh, sorry, I have to set this equal to 0. So let's solve that equal to, oops, I'm going to set that equal to 0, and now I'm going to solve. And clearly when I solve this first bracket, what would cause a 0 there? Well, that would be a 0. However, don't forget we already determined way up here that x has to be greater than 0, so we're going to throw that answer out. So either the first bracket is 0 or, oops, sorry. Or now this quantity could be 0, so I'm going to, if you looked at the note that was posted before, they solved it a little bit different. I'm just going to say this, I'm just going to set this equal to 0, and then so then I'm going to say log base 3 of 8x cubed over 2x. When I set it equal to 0, then I'm going to move the 3 to the other side, so equals negative 3 over x ln 3. And I know x can't be negative and x can't be 0 anyway, so I'm just going to cross multiply. So log base 3 of 8x cubed equals negative 6x over x ln 3. And then these x's cancel. So just don't forget what you're trying to do. You're trying to solve for x here. So again, I need to get rid of the log base 3 because I'm trying to get this x by itself, so don't forget the opposite of logging base 3 is raising it to the 3. So when I raise this side to the 3, the log base 3 and the 3 are going to cancel, and I'm just going to get an 8x cubed. Oops, I should have left that in red. But I have to raise this side to the 3. So 3 to the negative 6 over ln 3. And now it's just a matter of dividing by 8 and cube rooting. So x equals 3 to the negative 6 over ln 3. Divide by 8. Cube rooting is like doing to the 1/3. And when I do the numerator to the 1/3, the power to a power, you multiply. The 3 and the 6 cancel and make a 3 to the negative 2 over ln 3. All over, when I cube root the bottom, I get 2. And that is a good answer for x. And how do I know it's a good answer? Well, I know, again, don't forget your domain was that x had to be greater than 0, and 3 to the anything's greater than 0 divided by 2. It's going to be a perfectly fine answer. Okay. Determine the equation of the tangent at x equals 1 for log of x cubed. So this is a doable question. So I know we're not concentrating on the super hard ones, but this one isn't too bad. So you've done this lots of times before. Don't forget when it says the equation of the tangent, that's going to be y equals mx plus b. So your job really is just to find the slope of the tangent, and that's what's going to go in for m. And you know the slope of the tangent is really just the derivative with a 1 subbed into it. And then you're going to sub in a point and solve for b. So let's find a point first of all. So if when x is 1, y is going to be log of 1 cubed, which is log of 1. So don't forget y equals log. Don't forget the base on that is the 10, right? So log, which is log base 10 of 1. And you should be able to figure this out without a calculator. I mean, you could just take your calculator and type in log 1, make sure your base is a 10. Or you should be able to do this by hand. You should say, oh, I can rewrite the 1 as 10 to the 0. These cancel, and I get 0. So as far as having a point later on to sub in, we're going to have the point 1 comma 0 to sub in. And that will help us find the b. But for now, we're going to need to do the derivative. So y equals log of x cubed. So dy dx equals, to take the derivative, you're going to do, I always have to think about these rules, so I'm sure you will. So it's going to be 1 over the quantity you're trying to log, ln the base, and don't forget the base is 10, dot, you have to do the derivative of x cubed, which is 3x squared. And you should always be fixing these things up. So the x squared on top cancels with a couple of the x's on the bottom, so you're going to have 3 over x ln 10. And don't forget, we're going to find dy dx at 1. So when x equals 1, this is going to be 3 over 1 times ln 10, which is just 3 ln 10. It's a 10, not a 16. Okay, and now we can find the equation. So y equals mx plus b. I'll do this in green. So y equals mx plus b. We just figured out the slope is 3 over ln 10. I mean, if you really want a decimal for that, you could, but why not just leave it as 3 over ln 10? And then you're going to sub in your point, so we're going to sub 0, comma 1. So you've done this a million times. So 1 equals 3 over ln 10 times 0, thank goodness. And so b obviously comes out to 1. And your equation is y equals 3 over ln 10 x plus 1. Yeah, I'd like to backtrack on that. Can't believe I did that. See what I did? I subbed in the point 0, comma 1 instead of the point 1, comma 0. So it's not that I subbed it in wrong, I just subbed in the wrong point. So can we backtrack on that, because I don't feel like recording this whole lesson all over again. So let's sub in what we were supposed to sub in, which is 1, comma 0. Sorry about that. Okay, so let's sub in 1, comma 0. So how about we put a 0 in for the y and a 1 in? I thought that was too easy. I didn't remember the answer being that easy. So now b is going to be negative 3, because you're going to move that to the other side, so negative 3 over ln 10. So that's going to change our equation to minus 3 over ln 10. And again, that's just a number. And you can put that into standard form if you want. If it was in the back of the book, I'm sure it would probably be in a standard form. But yeah, okay. As far as the homework goes, so I've crossed off a bunch. If you have nothing to do or you're really bored at home and you want to do lots of calculus, you could do them all. But if you could do 3 to 6 and 7a and then maybe 1 to 4, and I know some of you have already worked through this because of last week, and I'm sorry we didn't really know how much we were cutting down the course at that point. So at least you'll know this stuff really well. But for the rest of you that haven't done anything, if you could work on 3 to 6 and 1 to 4, that would probably be pretty good. There might be a couple of wrong answers in the back, and look on the calendar because I did post quite a few solutions. And so if you don't get one, there may be a solution on there. So if you just go to the calendar from last week, under homework solutions, you'll see a few videos showing you how to do some of them. Okay.